We are now headed into chapter 6 for this course, and it's roughly called Structures. I call it Structural Analysis, and for me this is exciting because this is what I do. I teach structural analysis, I do structural analysis, I research structural behavior and structural analysis. So this is a lot of fun for me. So you'll have to excuse me, I just can't talk about this without geeking out a little bit. I'm not sure if this part of it's in the book, but I can't talk about structures without talking about what they really are. So structures are anything that resist forces. This is why you need to know statics, but they also serve a purpose. Here are pictures of various kinds of structures. Here's a bridge. That's a structure. It resists loads, wind and gravity, and it serves a purpose. You need to get from one side of the river to the other. This particular bridge, I can't remember what it is, but it's a cable-stayed bridge. These cables are straight and they're tensioned to hold it up. It's different than a suspension bridge, which is the Golden Gate Bridge. This might be the Akashi Straits Bridge in Japan. I'm not sure. Here's a building. This, of course, is the Burj Khalifa, tallest building in the world right now. They're building a taller one in Saudi Arabia, but right now it's the tallest building, and it's made out of reinforced concrete. It resists loads. It's interesting, when a building gets that tall, the earthquake loads are minor compared to the wind loads. And especially out there, there's high wind loads, and that's a big concern. But it resists loads, primarily gravity and wind, and its purpose, of course, is to house people. This is a sculpture, but it also is a structure. We had a former student come in. She had just gotten a job with a fancy structural engineering firm, and one of her first jobs was to design the structural part of this sculpture. It might have been this sculpture or a different one. I believe this actual sculpture. The artist wanted to do this. She had to make sure it would stand up. This is a stadium. There we go. Stadium is a structure. It resists loads of people and things like they might be jumping up and down in unison to rhythm as part of a cheer. There's all kinds of crazy things in terms of loads that go on in stadiums, and they serve the purpose of holding people up so they can watch a sporting event. This here is a structure. It holds up these signs. These signs, when you see them up close in person, are huge. They basically are giant sails that catch the wind, and this structure here has to hold the weight of the signs so they don't fall into the traffic, but they also have to resist the wind that's blowing on those signs. This is the new airport, well, relatively new airport, hotel out by the airport in Denver. And what I really want to talk about is this structure here. My daughter says this looks like Donald Duck wearing sunglasses, Ray-Bans, but I don't know. It's supposed to look like the wings that you get when you're a kid. They give you a little pin if you fly on a plane, and you get a pin that looks like that. That's what the hotel's supposed to look like. But this structure here, what looks like a duckbill, it's protecting the trains that come in from the elements. And the reason I want to point out this structure, it's a 3D truss, and we're going to learn about trusses in this chapter. It looks like that, holding up the glass. But the interesting thing about that is one of our students, after he received his master's degree, he worked for a company they didn't like. Then he moved to this company, and his first day on the job, they said, here, design this. He had to design that thing right there. So that's pretty cool. A long time ago, we used to separate structures like this. Bridges were considered civil engineering, and buildings were considered architectural engineering. This is still the case in Japan. In Japan, architecture is not what we call architecture here. Architecture in Japan is structural engineering for buildings, and civil engineering would be structural engineering for bridges. We did away with this nomenclature in the U.S., I don't know, 40, 50 years ago. But it's made a little bit of a comeback. We have here at the University of Wyoming, we do have architectural engineering, and that's engineering that has to do with buildings. So it'll be structural engineering, like what I teach, but it'll also be heating, ventilation, air conditioning, HVAC, and also energy audits of buildings, electrical systems in buildings, and construction of buildings. So we've brought this back. There are about something like 25-ish or so ARE programs in the country. So it's kind of unique to have an ARC-E program. Most other universities, they just took ARC-E or the structural engineering for buildings and put it into civil engineering. There are over 300 civil engineering programs in the country, and they cover all of that.